The acceleration of an object is always 4 feet per second squared. So that means the acceleration is constant. And we're talking about the position function x of t. So x of t is the position function. That means x prime of t is the velocity function, and x double prime of t, the second derivative, is the acceleration. And this is a constant 4 feet per second squared. Now, it tells us two things. If at time 1, the object is stationary, meaning it's not moving, in other words, the velocity, so x prime at 1, if it's stationary, that means the velocity is 0 because it's not moving at all. Now, if it also says that position is x of 1 equals 5. This is important because we're going to have to use an antiderivative to find what is the position function x of t. But whenever you do an antiderivative, you get a constant of integration, right? You get an infinitely many family of functions. So you have to have these kind of what we're called initial conditions. And that's what these really are here. These are what solve for those constants. So to do this, let's just take the integral of x, the second derivative of x, the x double prime of t. This is really just going to be 4, right? So we're going to take the integral of 4. We're going to do dt, and that gives us 4t plus c, right? But we know that this is our velocity function. We know that x prime of 1, which equals 0, equals this thing. So if you plug in 1, sorry, it's supposed to be a 1 here. 4 times 1 is 4. 4 plus c equals 0. That means c has to equal -4. So our position, or our velocity function, has to be 4t minus 4. Now we can find the antiderivative of the position function, 4t minus 4. Oh, sorry, this is the velocity function. The antiderivative of this is the position function. So doing this will give us, let's see, it's going to be 2t squared minus 4t plus a different constant integration. The actual, variable here doesn't matter, so I'm just going to use c again. But you could say this is like c1, and this is c2. It's all the same thing. Now we can use this initial condition, x of 1 equals 5. So that means x of 1 equals 5, which equals 2 times 1 minus 4 times 1 plus c2. Of course, that gives us 2, let's see, it's going to be 2 minus 4 is a -2 plus c2. That means c2 has to equal plus 2 over it's like it's going to give us 7. So that means that our position function has to be 2t squared minus 4t plus 7. So the answer is D.